Time travel has been one of humanity's greatest fascinations, inspiring countless books, movies, and theories. But is it just science fiction, or could it actually be possible? Welcome to Großdenken, everyone. In this video, we'll explore the real science behind time travel, what Einstein's theories say, what modern physicists believe, and whether time machines could ever exist. Please support this channel by subscribe and like. It would mean a great help. First, let's define time travel. Simply put, it's the ability to move through time in a way that's different from the normal flow, either to the past or the future. Technically, we're all traveling through time right now, moving forward at a rate of 1 second per second. But when people think of time travel, they imagine jumping decades into the past or future. The big question is, can we manipulate time using the laws of physics? To answer that, we need to start with Einstein's revolutionary theory of relativity. In 1905, Albert Einstein introduced his special theory of relativity, which completely changed how we understand time. Here's the key idea. Time is not constant, it's relative. Einstein showed that time moves differently for objects traveling at different speeds. This phenomenon is called time dilation. For example, if you were on a spaceship traveling close to the speed of light, time for you would slow down compared to someone on Earth. You could travel for what feels like a few years, but when you return, decades, or even centuries, might have passed on Earth. This means that traveling to the future is theoretically possible by moving extremely fast. In fact, astronauts on the International Space Station experience a tiny bit of time dilation because they're moving quickly in orbit, just a fraction of a second over their lifetimes. Einstein's later work, general relativity, added another layer to time travel. He showed that massive objects like stars and black holes can bend space-time. Imagine space-time as a stretched-out fabric. A heavy object, like a planet, creates a dent in that fabric, and time moves slower near the dent. This is why clocks on satellites orbiting Earth tick slightly faster than clocks on the ground. But here's where it gets exciting. General relativity predicts the existence of wormholes, or shortcuts through space-time. A wormhole is like a tunnel connecting two distant points in space and time. Theoretically, if a wormhole could be stabilized, it might allow us to travel to the past or future. However, there's a big problem. Wormholes are incredibly unstable. They would collapse instantly unless held open by a mysterious substance called exotic matter, which has negative energy. To date, exotic matter has never been observed, so traveling through wormholes remains purely theoretical. Traveling to the future is easier to imagine scientifically, but what about traveling to the past? This is where things get tricky. Time travel to the past creates a lot of paradoxes, the most famous being the grandfather paradox. Imagine you go back in time and accidentally prevent your grandfather from meeting your grandmother. If that happens, you wouldn't exist to go back in time in the first place. Some physicists believe these paradoxes make time travel to the past impossible. Others, like Stephen Hawking, propose the chronology protection conjecture, which suggests that the laws of physics prevent time travel to the past entirely. However, there are still some intriguing possibilities. For instance, closed time-like curves, a concept in general relativity, might allow loops in space-time where you could theoretically travel to the past. But again, these remain purely theoretical, and no experimental evidence supports them. So, are scientists working on time travel right now? Not exactly, but we're testing the principles behind it. At the Large Hadron Collider, particles are accelerated to near the speed of light, and their internal clocks slow down due to time dilation, exactly as Einstein predicted. This is a tiny example of how time can be manipulated. However, building a time machine requires unimaginable amounts of energy. To bend space-time enough for time travel, you'd need a star-sized object or something even more powerful. Another challenge is that quantum mechanics, the science of tiny particles, often clashes with general relativity. Until we discover a unified theory that combines these two pillars of physics, time travel will remain a mystery. So, is time travel scientifically possible? The answer is maybe. Traveling to the future is supported by Einstein's theories and has been observed on a small scale in experiments. But traveling to the past remains far more complicated and may be impossible due to paradoxes and physical constraints. But who knows? With advances in physics and technology, the future might hold surprises we can't even imagine. What do you think? Will humans ever crack the code of time travel? Let me know in the comments below, and don't forget to like and subscribe for more fascinating science content.